look for a few more people sign up, so just hang tight. Thank you.
It's only 3 till.
Okay, but I turned it on anyway. So.
Okay. I'm looking forward to playing tennis tonight.
Oh yeah, who are you playing with?
The usual group.
Usual group? Where?
DuPont.
Indoor?
Mm-hmm. Hey Bob, you're on, just so you know. Everybody in Hawaii and California are listening to you. Hold on.
It's still 2 minutes till.
I turned the room on.
Bob Glander.
Mm-hmm. Hey, Bob. How are you? And Bruce Fredrickson said he registered for the 3 o'clock.
Okay, we're going to get started. It's 3 o'clock. Hello, everyone. My name is Dan Jenkins. I'm the marketing director for Fuel Right. Really appreciate you guys coming out today at 3 o'clock. I just want to let everyone know we have a lot of variety of people on the call today. We have people in the fuel tank industry. We have environmental people. We have safety people. We have a lot of fuel dealers, several people in the cleaning fuel tanks, and we have several people in the involved in gauges, electronic gauges. That seems to be a topic today. So anyway, we're going to focus on solving corrosion and sludge problems in ULSD systems. This is a working webinar. You're free to ask questions. We're all in this together to stop this problem of corrosion, which is eating our gas stations. Some of the problems that most of you guys know are right here. Let me see if I get my pencil working. Let's see here. One of the main problems that we're seeing out there on the corrosion side is the filters are plugged with this coffee ground looking stuff. If you stuck a magnet in there, you'd see that is a rust and corrosion. That's one of the problems we'll be talking about today. And the other one is just good old corrosion. It's eating the tanks, eating the dispensers, and causing havoc out there. So we're going to talk about that. We're also going to talk about a lot of the pictures that people sent us along the way. This one happened to come from a gentleman in Virginia. He's tracking his tanks. He's tracking the corrosion and the spreading of corrosion with pins on the map. And he's got problems in his risers. All the way down to the bottom of the tank to all the way to the top of the tank. So we'll be talking about vapor spaces today, etc. The other thing we want to talk about today on the corrosion side, this is not just a downtime issue. This is a safety issue. So over on the left here, let's see if I get my thing going. We have some valves. I met a gentleman in St. Petersburg, Florida. He does warranty claims on tanks, and basically he told me, he showed me a 5-gallon bucket full of these valves, and they're causing the dispensers to stay open or stay closed. And so fuel is leaking, particularly when something hits a dispenser or a dispenser goes bad. So we're going to talk a little bit about safety today. Also down here on the bottom, you see another valve. It was from a major C-store chain. They had a whole room full of corroded parts. So again, we're trying to get to the bottom of what causes corrosion and what you can do to stop it. And then basically over here on the right, we'll be talking about a common problem is basically plugged fuel filters. So again, this is open conversation. Please feel free to ask questions. Like we talked about, it causes problems. The first problem is the slow pump, and customers leave. Pumps are out of service, customers leave. And hopefully there's no leaks, but leaks are occurring. I've talked to several people who've had leaks, and also several people who are concerned that dispensers are leaking, tanks are leaking, it's causing spills out into the public. So we'll be addressing all that today. The bottom line with all this stuff is managers get frustrated with corrosion. They call us, they're frustrated, their tanks are down, their trucks are stalled because they have corrosion that's eating their dispensers. The end result, when these people get mad, they tell their association. Their association tells other people. You end up with the Clean Diesel Fuel Alliance and the Battelle Report, which we'll be talking about today, which is the first step to really address this issue in an aggregate form. My name is Dan Jenkins. Again, I'll be talking a little bit about the myths today. There's a lot of myths in the fuel industry. We'll be debunking those. Bob Tatnall will be taking the bulk of the presentation. He's the architect behind Fuel Right. We also have Stan Smith, who's an experienced tank cleaner. He's going to talk to you a little bit about what tank cleaners and fuel polishers can do and what they can't do. Again, this is open discussion, so please feel free to use this chat room down on the left-hand side and ask your questions away. First, let's talk about some myths. What are myths? Myths are false stories with no fact-checking. Basically have no basis, and they're passed along and through generations of people, for that matter. So there's a lot of myths in the fuel industry. In fact, it's rampant in the fuel industry, and I want to talk to you about a few of them. Okay, myth number one, your fuel is unstable. So you fuel dealers out there, a lot of people might tell you, your fuel is unstable. Therefore, you should add a stabilizer to help prevent sludge. We believe that is a myth, and we're going to debunk that for you. Myth number two, algae grows in fuel, particularly in ULSD. We hear a lot of people in the marine industry and a lot of people in the fuel industry say, hey, I got my algae problem. I need an algicide or a biocide. Another myth. Myth number three, we hear this very frequently with people who are kind of in denial and say, hey, I turn my tanks over so much, there's no time for sludge or fouling to occur. In fact, a fuel dealer up in the Northeast advertises that he widely promotes that all his fuels are filtered prior to leaving his bulk plant. With our fuels, you're assured of fresh diesel fuel because of the rapid turnover of our products. So we're going to debunk that myth. The more you turn over your fuel, the better off you'll be. Myth number four is another myth, particularly rampant in the tank cleaning industry and the fuel polishing industry, that says if you have your fuel polished or your fuel cleaned, and the contractor shows you nice clean fuel over here. Again, it starts dirty, he starts cleaning it, and then it's clean. Therefore, if your fuel is clean, your tanks are clean. We think this is bogus, and we're going to tell you why. Myth number five, rampant in the fuel industry, that biocides are the answer, because if I kill the bugs, they can't cause problems. Again, great marketing. We're going to debunk that myth for you today. Another marketing myth is rampant in the fuel industry, pretty heavy in the C-store and the truck stop industry, is if you buy a detection kit, you can detect microbes and fungus growth. Then I can add biocides to kill them, and all my problems go away. So those of you who know about people who use fuel testing kits, we're going to talk a little bit about that today. And myth number seven, the final myth, is how to get water out of the fuel tank. There are plenty of products. Go to any big trade show. There's people selling products that will say they'll get water out of the fuel tank. And if you get all the water out, you'll solve all your problems. So we'll be chatting about that as well. Well, now I'm going to turn it over to Bob Tatnall. He's going to take over the bulk of the presentation. Take it away, Bob.
Thank you, Dan. For 30 years, I worked for DuPont as an internal consultant, engineering consultant, and my job was to help them solve equipment failures, corrosion problems, and specifically biocorrosion problems. I was a group leader in biocorrosion research at DuPont's experimental station in Wilmington for the last 5 years of my career there. And during that period, I was co-founder of the NACE committee on MIC, and I've published over 40 papers on subjects ranging from corrosion problems to tank linings to fuel properties, fuel stability issues, and controlling sludge, etc. And in the last, for the last almost 20 years, I've been working on developing and getting people to understand the fuel rate treatment for number 2 fuels to prevent sludge fouling and corrosion problems. And that's what I want to talk to you about. First of all, I'm going to explain what is different about ultra-low sulfur diesel. I'm getting some help here. We hear a lot of rumors about ultra-low sulfur diesel and a lot of things that aren't true and some things that are true but don't matter. And I'm going to try to straighten some of that out. And then we're going to talk about what actually causes fouling, sludge, and corrosion in diesel systems. First of all, let's talk about the fuels. We've had in this country, in my lifetime, 4 generations of fuels, number 2 fuels, diesel fuels, and each of these has unique properties and challenges. First of all, prior to the 1960s, we were primarily using what was called straight-run distillate. You simply take crude oil out of the ground, you put it in the distillation column, you separate it into its various products, and you sell them. And the one that came out of the second nozzle from the top was the number 2 cut, and that happened to be what we ended up using as heating oil and diesel fuel. And that was beautiful stuff. It was excellent fuel. But there was not a lot of it available because a drum of crude oil doesn't give you much number 2 fuel, doesn't give you nearly enough gasoline, which is a much lighter cut. And that's what we need in this country. And so primarily in the 60s through the 80s, we went to cracked product, liquid catalytic cracking. And so that drum of crude oil now, after it goes through the distillation column, everything that isn't gasoline or diesel fuel probably goes back through a catalytic cracking process and then back to the distillation column, and you end up breaking the big heavy molecules down into lighter ones, and you get a lot more gasoline, a lot more number 1 and number 2 fuels. And the problem with the cracked fuel of the 60s through 80s was it was by nature very unstable stuff. And so during that time, there were a lot of additive companies, and my former employer, DuPont, happened to be, I guess, the largest fuel additive supplier in the United States during that period. And everybody was developing stabilizers because that was the problem at hand. Well, as we came to the toward the end of the 20th century, we became more concerned about air pollution, sulfur pollution in particular, and the fuels we've been using up to that point were 2,000 to 5,000 parts per million sulfur. And so they were very polluting. And we were required to reduce the sulfur level for some fuels to 500 parts per million or less. And we brought in what we called then low sulfur number 2, which became the required standard for on-road diesel. And more recently has become the standard for off-road diesel. And was a good fuel. That was a very good fuel, and lo and behold, it was very stable again. And the reason being, in a nutshell, cracking makes fuel unstable by nature. Removing the sulfur makes it stable again. I could give you the 2-hour version of that over a beer sometime, but we'll leave it at that for now. But even at 500 parts per million sulfur, this fuel is still an air pollutant. And in the years since year 2000, we have been required to go to ultra-low sulfur diesel, 15 parts per million sulfur maximum. That is the national standard for diesel fuel. They've used lower than that in Europe much longer than we have, but they usually do lead us on environmental issues. It's now becoming the standard for off-road diesel, and in some states is the standard for heating oil. But it's the fuel of choice. Now, the properties are, again, a little different. Chemically, it's different. It's a different mixture of hydrocarbons than is any of the others. And it's a wonderful stuff, very stable, contrary to what some additive people who sell stabilizers will try to make you believe. And it has nice low pollution, or at least sulfur pollution properties. Unfortunately, in changing the chemistry of the fuel, we took out the natural lubricants, the aromatics that are lubricating in nature, and we removed also a lot of the conductivity of the fuel, so it now tends to hold and build up a static charge more than fuels used to. That is a concern at certain temperatures and in certain businesses. So we have to replace lubricity and conductivity properties on a selective basis. Older engines that aren't built to handle the poorer lubricity, for instance, need lubricity ingredients or additives. The point is that all generations of number 2 fuel have certain things in common. They're all mixtures of dozens, maybe hundreds of different hydrocarbon molecules. They're a virtual alphabet soup of hydrocarbons. They all contain paraffin and thus have cold flow issues. We know about those. We're not going to talk about those today. But they all support the growth of certain bacteria, yeasts, and molds when there's water present. Growing organisms require some water to grow. Regarding sludge, fouling, and corrosion, the problem is not the fuel, but rather the critters that grow in the fuel. This is a nice sketch that Dan found on another presentation, and we borrowed it for ours. It shows you graphically what we're dealing with here. Imagine that plate on the bottom is part of the side of a wall of a tank or any other surface in your fuel system. And you see that there's a kind of a greenish splotchy film on the surface. That's what's called a conditioning film, and it's a sought film that adsorbs from the water. Again, there must be water present, and that is an essential precursor for the next step, which is attachment of organisms. These little critters, these bacteria primarily, are floating around harmlessly in the fuel as individuals. They're not really growing because they're in fuel, not in water, and they're just hanging out. Bacteria can do that. We can't hang out without things for growth for long periods of time, but eventually they come in contact with the surface of the tank, for instance, and if the conditioning film is there, they will attach. And once they attach, they start to multiply, and they start to produce a material we call slime. This obviously was drawn up by a microbiologist. They like to call it an extracellular matrix or a exopolysaccharide or whatever. It's slime. It's a starch-like chemistry, very slippery in water, and it meets all our requirements for the word slime. This is their world. This is not a random material. This is a very structured material. We now know that certain bacteria, slime-forming bacteria, once they attach to a surface, start producing, and it defines their world. And this is a water world. If there's not free water sitting around, they can build this in. They can pull water out of the fuel. And they can only build their slime world to the extent that they can find water to fill it up. And growth continues. Other bacteria, you see here there are different shapes and sizes and colors represented. There are different strains of bacteria. They all come together and they set up shop near each other, not necessarily in contact with each other, but they become a real community of cooperating, consortium is the word used, and they help each other and grow together, and they form this growing biomass or biofilm, and it gets thicker, it gets larger, and at some point chunks of it start to slough off, and also individual cells will come loose and go out into the fluid. They're growing in numbers, many orders of magnitude more than we started with down here. And these little clumps of sludge or individual cells move along through the system and eventually contact a surface. And if they find a conditioning film, they attach. And the process continues. And this is how sludge spreads through not just your system, but the entire world of fuel, from refining storage tank to the end of the line where it causes the most problems. Now, unfortunately, we store and transport our fuels in open or vented containers. And because of this, nearly all fuels contain water and microbes. We'll call them critters. The fuel leaving the refining process at the refinery does not hopefully contain measurable water or microbes because the process excludes them. It destroys the microbes. It removes the water. But as soon as it leaves that pipeline, it goes right into a big tank at the refinery, that big field of storage tanks we pass by. That is where the problem begins. Those tanks accumulate water in the bottom. Some of them have virtual lakes in the bottom, depending on how carefully the refinery maintains their facility, and things start growing and contamination enters the system. Water in fuel. We see it all the time. People send me samples like this. A jar with water in the bottom and fuel in the top. Name a fuel: gasoline, kerosene, mostly number 2. Sometimes the fuel looks dirty and ugly. Sometimes the fuel looks pretty and clear. Sometimes the fuel looks colored. This happens to be a bio blend. But the water in the bottom can be very ugly as well, or not. It doesn't matter. This is a world ripe for growth of organisms. Now, water. Water is, of course, the chief element necessary for all this to happen. But water is a fact of life. Water in fuels is omnipresent once the fuels are stored. It can be dissolved water, dissolved in the fuel. I hear stories about how much water fuel can hold. And I've read many times that ultra-low sulfur diesel holds a lot more water than does the old high sulfur diesel fuel. It's exactly the opposite. Ultra-low sulfur diesel has a lower solubility for water, but you're splitting hairs. We're talking parts per million. Very little water is actually dissolved in the fuel. But that is dissolved in the fuel is invisible and generally doesn't cause a problem as long as it's dissolved in the fuel. It's a trace impurity. What happens is we get suspended water, either an emulsion or a haze. A haze is just a very, very superfine emulsion with the droplets so small we just perceive it as a haze. An emulsion can be larger droplets, denser droplets. Some emulsions are so dense that they are more like a paste, but they are in fact just little droplets of water suspended in the fuel. This is more of a problem, as we'll hear. And the other, of course, the other form of water is that free water layer in the bottom of the tank or whatever. This is always problematic. May or may not be present in quantity, and unfortunately it's just ignored and untended for years at a time. and is part of the reason why we're having so much trouble in our fuel systems. Now, these emulsions are suspended water. Let's talk a bit about those. If this were pure fuel, just pure fuel out of the refining process, with water, just pure water, you would not have suspended or an emulsion, because water and oil don't mix. How many times have we heard that? If they're pure, that's true. But we get chemical surfactants, surface active agents, detergent-like materials that get into the fuel or into the water, and they will cause water to suspend in fuel. These surfactants can come from some additives that are used, or they can come from microbes themselves. And I want you to just, if you will, imagine these microbes, I told you, can only grow in water. They can survive in fuel, but they can only grow and prosper in water. So they found water, they set up shop, but they want to, some of them want to feed off the fuel. How are they going to get the fuel into the water? So nature has programmed them to manufacture natural surfactants. These are powerful surfactants. Some chemical companies have tried to understand them and copy them. They're so good that let them pull water and fuel together. And these emulsions or suspended water in the fuel, just the haze, can support the growth of critters. They can extract it. They can accumulate it. But also, this wet fuel, I'll call it, fuel with water suspended, itself can cause rusting of steel and cast iron parts. And that is a part of what we see in the corrosion of ultra-low sulfur diesel systems. Suspended or emulsions in water are usually bad news, but not always. There are exceptions. The microbes we talked about are bacteria and fungi, not mushrooms, but rather yeasts and molds of various sorts. These are the sorts of critters that are willing and able to grow in fuel systems. These microbes can come from the air, from water, from dirt, from debris, anything that reaches or comes in contact with the fuel, and they're always present in stored fuels to a greater or less extent. They aren't always a problem. That's important to understand, but they're always there. They tend to cause problems, including sludge, fouling, and corrosion. Sound familiar? And the other thing to keep in mind is that now at this stage where we have been moving fuels around the system, the entire supply chain may be contaminated. This doesn't mean that every tank and every barge and every pipeline has a big accumulation of sludge, but they all probably have some degree of contamination that can be moved from site to site. And it's quite possible that the conditions where one tank, for instance, is located maybe are too cold or too hot to support good growth. So not much is happening in that tank. So fuel is pulled out of that tank, a little bit of sludge with the fuel. It's moved to a new location that's more comfortable for them, and they take off, and suddenly problems occur. Where did this come from? Well, it came from a tank where it wasn't a problem before. Something to keep in mind, and also the vessels, the trucks that we use finally to transport the fuel to the end point, very often are contaminated. They're contaminated with organisms, they're contaminated maybe with a little water on the surface, and maybe some products that were hauled earlier in the truck. And if they're washed to remove the last load of product, they're left with a little water for the next load. So they're part of the problem. The sludge that we are most aware of today, the sludge that's getting the attention today, is this sort of stuff. It's this not black usually, but reddish, brownish, sometimes grayish looking slimy stuff. And we see it in filters, we see it in tanks, we see it in headspaces and filler necks and on filler caps and on all those parts that Dan showed at the beginning. It seems to be showing up a lot of places in fuel systems, and because we can really see it, it's really getting our attention. And of course, because it comes up into the vapor space and the head space, it's affecting operating parts other than the tank. And so we feel a need to deal with it. In fact, for years and years and years, we ignored sludge that was even worse. And I call this classic fuel oil sludge. Whether it's in diesel fuel or heating oil, it doesn't care about sulfur levels. It grows very nicely on filters, and these filters are from heating systems and also the one in the middle from a diesel system. This is a pump strainer from the heating system. Any place where the organisms can land and receive the nutrients and the things they need, and a filter is the most accessible and optimum place for them to grow. And what happens, these filters won't pass fuel. They plugged. That's all we know. And we look at them and we say, oh, we had a lot of dirt in the system. It's not the particles so much, but the slime that is formed, that grows or is formed by growing organisms, that really seals these off and plugs the filter more than the particles themselves. Now, this classic black sludge that we ignored for so many years, what is it made of? It's made largely of water, as I mentioned, fuel, but degraded solid fuel. And we could get into an argument about how this compares with the solid fuel that happens from fuel instability. There are similarities, there are differences, but this is fuel, solid fuel that occurs in biological sludge. Trapped particles and debris, anything that got into the system, dirt, sand, and of course corrosion products. If this is in a steel tank and there's iron oxide from corrosion, you get a lot of iron oxide in this, and the stuff will feel crustier, harder. And of course, it's all bound together, as I said, by bacterial slime, the glue that holds it together. Well, the sludge today isn't that different. The sludge today, though, what is lacking that the old sludge had was all the blackness for the most part. And one reason is that a lot of that blackness came from metal sulfides that were formed when metal corroded in the system, and the metal ions reacted with sulfur ions in the fuel and formed black metal sulfides, and it colored everything very black. Well, with ultra-low sulfur diesel, no surprise, we don't have a lot of metal sulfides because there's not much sulfur there. So we tend to have sludge that's colored sometimes more by iron oxide, such as this. So it doesn't look the same, but it's very similar. This tends to be very crusty. Now, this picture on the left is the bottom of an old, nominally 50-year-old home heating oil tank that failed, only lasted about 50 years. And these white little arrows indicate where there are through penetrations. These are little holes, tiny holes, as if they were drilled with a small drill bit, straight through the metal. The metal on all sides around them is full thickness. So this tank is not thinned, it just leaks. And this is the most common type of storage tank failure in number 2 fuels. In the bottom area where water collected first and sludge grew, we get pitting corrosion and we get penetration, and some people are promoting the use of ultrasonic calipers to check tanks for thickness. That works in the industrial world. In home heating oil tanks, it doesn't usually work because, as I said, the ultrasonic gauge is going to say this tank has full thickness, and you could not measure where there's a pit. It's simply you wouldn't get an indication, so it's invisible to those sorts of instruments. Now, this could be considered, to a lot of people who looked at this, a water pipe, because this is where what a lot of water pipes look like on the inside. All this buildup. This is biological buildup, biomass, but it's hard, it's crusty, it's loaded with iron oxide, and it's formed by slime-forming bacteria, and they would be found in there as with their slime, but there's so much crusty mineral material in this mixture that it doesn't feel slimy, it feels crusty and hard, almost like rust, but more frangible, like dried mud. This happens to be out of a fuel line, so it obviously with a lot of water in that fuel, probably suspended water, probably haze or emulsion. Now, as we pointed out The biggest difference between sludge and fouling and ultra-low sulfur diesel versus the old classic black sludge is in the color. They're both biological, they both contain the same elements. It's just that the ultra-low sulfur diesel looks different for the reasons we outlined. But the first things we see for most of us, especially if you operate a C-store or a fueling station, the first signs that you have a problem might be slow pumps, dispenser issues in general, dispenser just not functioning, and the fact that filters need to be replaced frequently. And if you see those things, it's most likely you're dealing with sludge and fouling problem. And if you have sludge and fouling, you probably have corrosion, which may or may not be really serious. And this is just another picture of a different type of filter being pulled from its container in a ultra-low sulfur system. These are typical pictures of the sort of parts that Dan showed at the beginning in ultra-low sulfur diesel C-store dispenser type systems. Notice that tanks with ultra-low sulfur can still have that fine pitting corrosion. It's hard to see, but there are some pits in this tank and some larger pits that haven't penetrated. So that is still going on. The old sludge problems haven't left us. We've just simply superimposed new ones that extend into the vapor space. And this is an example here in this check valve compartment. And here's a riser leading to the pump. The riser looks like it's mostly got the fouling here. So this is the form we mostly associated with ultra-low sulfur diesel corrosion. How quickly does it occur? Well, this is a steel panel from laboratory test where free water, a layer of free water, is purposely put in the container and filled with diesel fuel, ultra-low sulfur, and a little bit of sludge contamination off a filter put in there, and then nature allowed to do its job. And this corrosion and failure occurred in less than 18 months. Notice it's not pitting, it's general, it's localized corrosion. Localized non-uniform corrosion is the term corrosion engineers use for that. It's significant, and it didn't take that long to happen. So finally, to review about corrosion, corrosion will occur when free water is present and when sludge grows on metal surfaces. I want to touch on this Battelle report. The Battelle Institute was commissioned by a group representing the organizations that oversee our fuel situation, the API, etc., in the United States, as well as some of the major suppliers. They pooled their resources and they said this ultra-low sulfur diesel corrosion problem is an issue. We need to understand it. We need to deal with it. So asked Battelle to start by looking at some tanks affected by it and see what they can learn. This was not an in-depth study. It was not a full research program. Battelle was given limited resources and limited scope, but they looked at 6 underground ultra-low sulfur diesel tanks to just see what they could deduce about the causes of this problem and the scope of the problem. And they concluded that the corrosion was probably caused by acetic acid generated by bacteria from ethanol contaminant in the fuel. Now, presumably this ethanol would have come from cross-contamination if gasoline, gasohol were shipped in the same container. It wouldn't come from pipelines because ethanol is not shipped in pipelines. The gasoline without it is usually piped there and the ethanol is brought in by truck and blended. But it could happen in terminals, it could happen in delivery trucks, it could happen in over-the-road transports. Anyway, that was their presumption. And I might comment that these type of bacteria that they found using modern techniques are not mentioned in classical references in the literature as being organisms normally found in hydrocarbon fuels. So it was interesting. But because of the limited scope and the limited funding for this report, it didn't provide really good science. And it was frustrating. And so I think the industry is hungry for a follow-up study, and I hope that it will be as good as Battelle is capable of doing. That describes why we have these problems to the extent that we understand it. We'll talk about what we do about it in a bit. But are there questions at this time? You might be thinking about your questions. If you have some, type them on the lower left, and when we have take a breath, we'll stop, read them, and talk about them. But I think I'm going to move on to the next phase. Now, we're supposed to have Tom Fulkelson checking in from the West Coast, but I understand Tom has had technical difficulties tying in, and so we're going to let instead my good friend Smitty, Stan Smith, who is going to talk about tank cleaning, but we're going to let Smitty first talk about the subject of fuel polishing, where it fits in, and then after he's done, he will introduce himself and then tell you about tank cleaning. So I'll turn it over to Smitty now.
Good afternoon, everyone. Hi, Bob Glander. Hey, Bruce Fredrickson. Hope you guys are doing well. You're stuck with me talking about fuel polishing because Captain Tom got something wrong with his computer. The real question that we're bringing up here is, what does fuel polishing do? What does it accomplish? Where does it fit in the picture? Fuel polishing is just super filtering of the fuel that's in the tank. It doesn't do anything but try to take whatever contaminants might be in it out of it. If you look at the screen up there right now on the bottom center, on the right is the finished product of fuel polishing. You can see at that moment in time, it sparkles, it's clear, it's bright, it's brilliant. Somebody's playing with me here. How do I go back?
Here, I'll get you.
The one on the left is cloudy. That was the fuel before they started polishing it. Might have had some water in it, might have some trash down in the bottom. Fuel polishing is almost a fantasy. And the problem is it doesn't clean the tank. When you look in a tank, which you're looking at in this slide, you can see stuff on the bottom, you can see stuff on the sides. But the problem is you're only getting what moves with the fuel. You're not getting the trash and dirt out of the tank. It might remove the free water, but any pumping will do this, and you got to have a water separating filter to get it out, or you're going to put it right back in. It removes some loose debris or metal pieces or whatever, but it's only what's right at the suction. You're not getting in the tank, and you're not cleaning the tank out. So whatever contaminants there are that made the fuel look bad are going to come back quickly. It gets the bottom sludge and asphaltenes, but only right where the suction is again, and that's the big problem. You're not really cleaning the tank. If you go in with a gamma jet, you're using high-pressure fuel sprayed back into the tank to kind of wash the sides down. Everything more you do does a little bit more, but it does not clean the tank. I've been talking against fuel polishing here, and if you just go through and read this, it's nothing more than a heavy-duty filtering system. It does not address suspended or emulsified water. It doesn't do anything with the acid value that caused by the bacterial waste. It does not get in the hard-to-reach areas. It does not remove any microorganisms that are growing and attached to the walls or the bottom of the tank. It never stops the growth of the bacteria. It's a short-term cosmetic solution. It is not a long-term fix for corrosion or sludge or slime. Now there you're supposed to hear about me, and this is where I'm supposed to start. I'm going to talk to you about tank cleaning. And what we're going to do is we're going to go through the different ways of tank cleaning. You can see in the photograph on the right, you got a pressure washer on the trailer, you got a vacuum truck, you got guys putting on their raincoats and Tyvek suits in the top left. You're putting trash into a drum to haul it away. With tank cleaning, you actually go into the tank, if it's big enough, and you squeegee the sludge and slime and dirt out You might pressure wash it, you might sandblast it. On the smaller tanks, which is where the fuel polishing works best because you can't get into them, so you do what you can by sucking out and cleaning the fuel. The larger tanks, you actually go into it, and it's confined space entry. You scrape and shovel, you get a little bit of cleaning. The problem is the sludge comes back quickly. If you use a high-pressure water blast, or even better yet, a high-pressure hot water blast, you're doing a better job, but it's expensive because now you got oily water to dispose of, and instead of whatever solids you have, and the growth still comes back quickly. I'll tell a story about this at the end of my little spiel here. If you follow the water blast by a sand blaster, you're doing a better job. The microbes actually attach and grow into the steel, so you're sandblasting them out, but it's destructive. You're wearing the tank out. You're taking a layer of steel off of the tank when you sandblast it. You're making a whole lot of debris that's hazardous and has to be disposed of, usually in a landfill, which is not really the best place. But regardless of what you do, cleaning is not perfect. And it's very difficult to get all of the microorganisms out of the steel and out of the sides and bottoms of the tank. You're constantly, the more you do, the more you sandblast, the more waste you generate, and the more the cost goes up. The benefits are it provides a short-term, maybe a year, maybe 6 months, maybe 2 years of protecting or eliminating the bacterial growth, but they come back. And it's the surest way to quickly get rid of the accumulated sludge because you're going in with squeegees and shovels in a back truck and you're sucking it out or shoveling it out. It's expensive. You got to take your tank out of service for an extended period of time. The workers are in there. It's confined space, another layer of OSHA rules that you have to follow. It generates lots of waste that has to be disposed of. And again, it's not a permanent fix. Now, before Bob Tatnall comes on, I'm going to tell you the story that I talked about earlier. The Army Corps of Engineers in Haven Point in Jersey City operates a tugboat called the Hayward. Kind of a special boat to me because we've fueled this boat for 25 or 30 years. We've seen it go in for its 5-year inspections and come out. And somewhere around 2002 or 2003, they started having filters plugging. They showed them to me. It was black, slimy, greasy, gooey stuff. They decided that the boat was due for a 5-year inspection. They put it into Cadell Dry Dock. They cleaned the tank out. They pressure washed it. They mucked it out. They did everything that they thought was the right thing to clean the tank. We put the fuel back in the tank. They put the boat in the water. The boat burns about 7,000 gallons a week. We go up every 2 weeks and put 2 loads on. Sometimes it might be 3. But 6 or 8 weeks after the boat came back, the chief engineer who's in charge of receiving the fuel came out. His name's Tony. He and I have done work together for many, many years. He says, Smitty, I don't want you to get mad at me, but my boss says I have to inspect your pump and your hoses because we think you're delivering black oil, 6 oil. I said, hey, Tony, fine, here. We took the dust covers off, we opened the valves, we let them look inside. Naturally, there was nothing black in there. Took the cap off the hose, looked inside the hose, it's clean. He says, I don't understand it. We had the tanks clean, and in 8 weeks, we got filters fouling up again. Well, what they did is they didn't sandblast, and they didn't get the sludge off the side walls and the bottom of the tanks. It just grew back right away. And with that little story, I'm going to give you back to Bob Tatnall. Thanks, folks. Was I too loud?
Thanks, Mike. Hey, Bob, we got a couple questions first if you want to tackle those right now.
Right. Let me zip up here, see who came first. Okay.
Jay Bogrand.
Okay. Is there a difference between microbes originating in fuel versus microbes with water in tank? Boy, I don't know. You'll have to ask the microbes. There are many, many, many different strains of microbes in either one. And I think that there are a lot of common, there are a lot of ones that, one of my favorites I love to talk about is Pseudomonas aeruginosa. Now, I'd be the last person to throw a lot of names around. I don't speak yet Latin, but it's one of the most common types of bacteria in the world. It's in our bodies, it's in our drinking water, it's in lakes, ponds, it's very common. It is a slime-forming bacterium, and we drink it every day. However, it's also the organism responsible for cystic fibrosis. It's also the organism primarily responsible for urinary tract infections. And some of you might remember the beautiful model in South America who a few years ago had a bacterial infection, and they had to amputate her limbs, and finally she died anyway. That was Pseudomonas aeruginosa. This is a strange but almost everywhere appearing critter. He grows in water, he grows in fuel. He's one that's commonly mentioned. So there are some types of organisms in both. There are always some types only in water, not in fuel, and vice versa, I'm sure. And I've read books on both, and the names can make you dizzy, but the fact of the matter is, before we start naming too many bacteria, it's only in the past decade that we've developed the tools to really accurately know what type of bacteria we're talking about. So that's a fancy way of saying I don't know. Okay, let's move along.
Okay.
Bob Takborian. After we pump the water out of our tanks, we seem to always get some water back on the next delivery. Is this common? Yeah, Bob, water's common. It's common in fuels. It's unfortunate. Years ago, I was consulting for a big chain in the southern states, gas station chain. They were getting a lot of water in their tanks, and they were pumping a lot of water into automobiles and buying a lot of replacement engines as a result. And they asked me to come see what the problem was all about. Well, I found all kinds of reasons for water in their tanks. Some of the older stations, the apron would have the fill point where they filled the underground tanks was the lowest spot on the apron. So every time it rained, the fill spot was in the middle of a small lake. Well, of course, when the truck drove up at 2 a.m. to drop a load in their tanks, that driver isn't going to remove that water. He reaches through the water, fumbles around, finds the opening, pops the lid, pops the seal off the top, and all the water magically disappears into the tank. Water is going to happen. Condensation is always mentioned as probably one of the least important sources of water. It comes from leakage, rainwater, groundwater leakage, handling water, transferring water in the rain or the snow. It can come from any number of places. Ships, boats, barges, and such that haul fuels very often use water on the return as a ballast. And they may pump it all out before they refill with fuel. They may not. I don't know. Some are probably better than others. I was looking at this gas station chain asked me to look at some of their suppliers' facilities and see if that was a problem. They gave me the names of 3 different terminals that they bought from. This was in the state of Mississippi. And in that area, they used 3 different terminals. And so we visited all 3. One of them was clean as a whistle. You know they did everything right. You know they drew the water off the bottom of those tanks weekly like they were supposed to. It would just run like a tight shut. One of our jobs was to go on top of one of their tanks, gasoline storage tanks, and open an opening in the top of the tank and lower a bacon bomb to the bottom and pull a sample and test it and such. And we tried to get near the center of those big tanks because they're all conical bottom with a water sump in the middle and then a 2 or 3 inch drain line, water line that ran out past the dike to a valve where they drew the water off periodically if they wanted to. And so we always tried to get our sample near the center of the tank. And the samples we got on the first 2 places were good looking samples. Anyway, the 3rd place, well, it was a little bit shoddier. We could see it wasn't quite maintained as well. And the owner was pleasant, but he said, look, I apologize. I'm going to take you up on this tank, but the only access we have is right near the outside edge of the tank. So we said, we'll take what we can get, even knowing that being a conical bottom tank, the slope is going to go up, and the highest point in the bottom is right around the perimeter of the tank. That's where we drew our sample. Our bacon bomb came up full of water. So there's a good chance he was delivering big chunks of water with the fuel. Now, if that weren't convincing enough, toward the end of our survey down there, we went to one of their larger and newer fueling plazas, a nice large place, beautifully sloped, everything looked beautiful, and my buddy and I had both sampled the plus tank, and he moved over to the regular and I moved over to the high test, and we were going to sample those and do our job and get out of there. While we were doing that, we were starting to pack up, and they said, you know, while we were doing our thing, a transport pulled up and dropped the load into the plus tank. Should we test it again? I said, well, why not? We're here. Let's just say we did it. So we went over and we stuck the tank. We stick them for water with a pole, of course. And when we did it originally, arriving at that site, we got something between 1/8 and 1/4 of an inch of water in the bottom. Very low, very low. When after that transport had left, we went over and stuck the same tank, and we had over 3 inches of water in the bottom. So you tell me, can it happen a lot? Can it happen big time? Yes. I wish everything were perfect, but so that water was delivered with the gasoline. What really hurts is it costs the same thing per gallon as the gasoline did. Okay, Steve Grisell. How do you explain the inconsistencies across the country where some geographical areas have a problem and some don't? The ULSD has been on the market since 2006. Actually longer than that, but maybe in your area it was started in 2006. But that's a good question. That's one that I ask people too, and they haven't given me a good answer, so I can't give you a good answer. I liken it to the common cold. Why does one person in an office have a terrible cold and the other 2 workers that work nearby don't get a cold? Well, that may be different. That could be personal immune system being better. But with heating oil systems, we used to deal with this. We had situations where 2 homeowners lived almost next door to each other, had similar age and type of heating systems. Tanks were put in the same time when the area was built up, and they both got their oil from the same oil company, which meant they both got deliveries for the same truck on the same day. And one of them was having big time sludge problems and the other wasn't. Why? Well, part of it might be the luck of the draw. Maybe one of them got a slug of contamination with their load and the other one didn't. Maybe one has a lot of sludge in their tank, but for some reason it just hasn't made itself out of the tank yet. It's hard to say. I don't know. That's a good question, and I wish I had a better answer. If somebody else has an answer, type it in. We'll spread it. Chris Hill, what would be the typical rule of thumb for tank cleanings, i.e. clean tanks every year for sites that say 50,000 or more a month in diesel, etc.? Well, I'm going to answer that with another question, Chris. Why clean your tanks at all? It may not be necessary. Smitty, do you have any rule of thumb?
No, not with installations on shore, just the marine side or the bulk storage terminal, where they have to do it to meet an OSHA or a marine requirement. The tugboats or ships have to go dry dock every 5 years to get inspected and checked.
Smitty talked a little about regrowth. Regrowth is a peculiar thing. The people who study biofouling got me intrigued in this subject back in the 1980s. If you take a biofilm and you wipe off 98% of it and you leave a little bit on the surface, that biofilm grows back at an amazing rate. It's almost like those bugs underneath were in hiding, and you suddenly open up their world and they go crazy. I don't know. So if it's hard to put a time schedule on it. I'd say the best time is to clean your tank just before you start having problems. And if you want to loan me that crystal ball, I'd like to use it for other things. But I would suggest that most people who clean tanks, as Smitty said, are doing it at a frequency mandated by some regulatory requirement, like for tank inspection or something of that sort, or people who are having continuing persistent problems with plugging of filters and such, and just want to just nail a problem, and they just send somebody down there to just clean it out and be done with it. Well, of course, as Smitty explained, they cleaned it out, but you're not done with it. I would like to propose, and this is jumping the gun, but I'm going to get to this quickly. I would like to propose the best answer might be to go do a cleaning, even if just a quick and dirty cleaning, allow the sludge out, and then do something to keep sludge from reoccurring, period. And then you've done your last cleaning. We'll get to that in a minute. Okay, Steve Grissel again. What are your recommendations regarding fiberglass underground storage tank cleaning periodicity? Ooh, I love that word. How often and what do you base this recommendation on? Okay. Well, having worked with fiberglass a lot for DuPont, I would tell you I get scared at anybody going into a fiberglass tank to clean it, especially with metal implements. Fiberglass tanks depend on that thin resin-rich layer on the inside to be the liquid containment, and everything else is structural material to hold it together. So if you go in and damage that inner 32nd of an inch, say, layer of resin-rich material, you have just defined when the tank's going to start propagating a leak. And when you're going to discover the leak is sometime after that. Fiberglass tanks, if it makes you feel any better, fiberglass tanks generally do not grow sludge as rapidly as do steel tanks. Steel is the most attractive, fastest growing substrate for sludge for some reason. And we could sit around and speculate as to exactly why, but I can tell you I have consistently seen that. So if we made our tanks all out of fiberglass or polyethylene or stainless steel or something else that's not steel, we wouldn't be having quite as much of the problem that we're having. I'm not saying we wouldn't have it. I'm just saying it wouldn't be as big a problem. We grow sludge in glass jars, so it doesn't have to be in steel. Okay, I'm going to move along, and I hope I got your questions adequately. If not, ask again. What do we do? What do we do? First, I want to just quickly nail those myths that Dan talked about, and some of them you've already heard the truth. I'll just remind you, ultra-low sulfur diesel fuel is unstable. I've already told you, ultra-low sulfur diesel fuel is usually very stable. It's a beautifully stable material, and normally there is no reason you would need to add a stabilizer. There are certain special situations that can cause instability, and those we'll save for another day, but they don't involve sludge fouling and corrosion. Algae are not a problem. This is semantics. Algae are microscopic plants that need sunlight. They use chlorophyll, and therefore they're one type of critter you don't find in fuel systems. I don't know where we came up with them. They're little guys. I guess that's why we started calling things that grow algae. But it makes me wonder about companies who are proposed to sell a technical product to treat algae in tanks. The more rapidly you turn your fuel over, the less sludge and fouling there will be. Well, I can understand why you might think this, but the fact is there's no basis in science for that. It might be that stations that have high turnover also have better maintenance. I don't know. But maybe they do a better job of keeping the water out of their tanks. There may be other factors that aren't obvious. But as far as the bacteria are concerned, I've already told you, they can only use probably 1 or 2 or 3 of the hundreds or so fractions in that fuel. There is very little that they can use in that fuel, and therefore they probably, as with most organisms in nature, they are probably semi-starved almost all the time. And the worst situation for them is a stagnant tank because they use up what's available to them. They can't reach what's far away in the tank, and so they kind of go into dormancy. Things just slow down. But you change the fuel in that tank frequently, you're giving them lots of fresh food all the time. Now, where is more growth going to occur? We see this in our tests in the laboratory, in our jars. If we don't change the fuel every month, everything shuts down. If we change the fuel every month, we get good, healthy growth and lots of sludge formation. So, so much for turning the fuel over rapidly. Oh, I want to mention, consider filters. The first place in systems where sludge grows fast and is apparent is on filters, because the fuel is going right by with everything the bugs need. Any suspended water, the food fractions they need, etc. Okay, we talked about fuel polishing. It doesn't really clean the tank. It cleans the fuel and it makes you feel good for a while, but all you're really doing is removing a lot of the competition for that limited food. All those free-floating organisms now aren't there. They've filtered a lot of them out. All the ones still on the surface are there with more fuel than ever to work with. Biocides, big one. Biocides, on paper, would be the obvious answer. Bugs are the problem, let's kill them, be done with it. Even good biocides, and I could mention one or two that are very good biocides. There are a lot of that aren't good biocides on the market, but there are a couple I really like. They're really good in a petri dish. The problem is that in a biofilm, the biocides have trouble penetrating to reach the cells, and they actually have to contact the cells to kill them. So again, biocides are very effective against free-floating organisms. They can reach them. What are you doing again? You're removing competition for the food from the ones that are really bothering you on the surfaces. So that probably explains why biocides usually give little long-term benefit. Now, detection kits. I look at those as a good way to sell biocides, because you're almost always going to have critters in the fuel, and if you have a good kit, you can see lots of growing critters, and people are going to say, oh boy, I better treat with your biocide. Again, I harken back to the last point. Are you doing yourself a favor? Now you buy a kit to show you have a problem, a kit to show you solve the problem, and all you've done is to buy biocide and make your problem perhaps even worse on the surfaces. Removing water. Some additives do have alcohols in them that can hide water in fuel. Some of the higher alcohols actually can cause a molecule of water to link to a molecule of fuel, and the water goes into the fuel and it looks like it's dissolved, but it's really just hiding there. And you aren't removing it from the system at all. Now this wet fuel is corrosive, it's causing rusting, and the alcohol is good food for bacteria. The way to get water out is with, as I said, mechanical means, once it's built up to be a problem. So how do we stop all this? And I thought you'd never ask. The answer, there may be more than one answer. The answer that we know about and I want you to consider is what we call dual filming amine technology. Now, filming amines are not new. But a combination of certain filming amines does some interesting things. For instance, it dissolves the slime that we talked about. The glue, it literally dissolves it into the fuel, where it just goes through and burns up harmlessly. There goes your old sludge, because all the binder is gone, the particles are released, the water is released into the fuel. It all just either gets caught on a filter or goes through and burns up. The filming amines coat all wetted surfaces in which they come in contact. And what we don't fully understand but have observed time and again is that bacteria choose not to attach to these surfaces with that film. Now, maybe the film is precluding the conditioning film I talked about, or maybe they just don't like the amine film. I don't know but But the important thing is that slime-forming bacteria do not make slime unless they're attached to a surface or attached to something. So by keeping them from attaching to things, they're not making slime, therefore no new sludge. And the coating, and this is what filming amines have been used for generations, the coating also protects the steel and iron surfaces against corrosion, even if there's free water in the tank. We have nails sitting in water in the bottom of a jar treated with filming amines that after years are still bright and shiny like they're right in the box. And there's more that we've discovered or others have discovered for us. These amines are very good cleaners. They're very good surface active agents, and they clean injectors. They clean nozzles. They clean along with other things, but they also lower, because they're surfactants, they lower the surface tension of the fuel. And the combination of clean injectors and lowered surface tension improves atomization, and I don't need to tell you that's important in clean and full and proper burning of the fuel. And that probably explains why people who have used this technology say to us with much surprise, the engine doesn't smoke like it used to. Now, the amines act as microemulsifiers. What do I mean by that? We talked about suspending water in fuel. And I told you it's usually bad news, but not always. Well, if the amines are the emulsifiers that pull the water into the fuel, it comes into it as a tiny, tiny, tiny droplets, so fine that it only looks like a slight haze and never settles out. Instead, it just goes through and burns up in the engine or the heater and makes a little steam. And the best part is that because this water droplet is treated with the filming amines, it doesn't cause rusting and corrosion in the system. And one other benefit is that this amine film on the surfaces acts also as a lubricating film and reduces metal wear in pumps and such. Depending on the engine and the particular pump and the level of treatment and the level of lubricity in the fuel to start with, it may mean you don't need to add any lubricating ingredient, or it may mean that you add much less to get the same benefit. In any case, it helps with lubrication. So in other words, with this sort of treatment, dirty tanks clean up, clean tanks stay clean, and corrosion of wetted surfaces stops within days. Think about this. Stops within days following the first treatment, even though the existing sludge takes much longer than that to go away. So what that says is the amines penetrate the sludge to stop the corrosion of the underlying steel, which I think is fascinating. And basically, diesel systems work the way they're supposed to. And the product we call is Feel Right. We alluded to that at the beginning, and what do people say about it? A lot of what we talk about is what people tell us. They note right away how easy to use, that there's no special handling required. It's very economical, especially compared to biocides. And it's very easy to measure success because things happen quickly and almost always in the right direction. So problems just stop. Things just clean up. Does it work? These are two of my favorite show and tells. These happen to be filters and pump strainers from heating oil system, but it could have been a diesel system. And they happen to be removed by the same service tech on the same morning, and they really caught his attention. The pair on the left, these both represent nominally 1 year of service. The pair on the left come from a longtime customer of theirs, and this company treats all their heating oil with the Feel Right product. And as he said, this is what we usually see. This is what we expect to see. A filter that looks like it's never been used. A strainer that you're tempted to put right back in. The one on the right was the next house he went to for annual service. And that happened to be a new customer who just came to them who needed service. And this is what they found. And it really got this guy's attention. So he gave those to me, and I love them. Now, I want to just touch on the Battelle report before we go to questions. I told you that it was limited in scope and didn't have a lot of chance to have good science But if you look not at the report that the funding agencies published and put in magazines, but the raw report that Battelle sent to them, and I say that because the agencies who sponsored the report before they published it thought, well, we don't want to mention brand names and things that, you know, we don't look impartial if we do that. So they cleaned up some of the details. Anyway, if you look at the original report from Battelle, a few things were interesting. The way they looked at these 6 tanks to see how fouled they were was they took samples the same way from all 6 tanks and tested for total DNA. And this total DNA analysis gave them an idea of the relative amount of fouling stuff growing in a tank, living stuff. One of the tanks they looked at because it was supposed to represent a tank that didn't have problems. So they wanted to see what was different about this tank. And lo and behold, very high in total DNA. And they realized that tank was badly fouled. The problems just hadn't made it out of the tank yet. And the lesson learned there is don't assume your tanks are clean just because your filters aren't plugging yet. Anyway, another tank they looked at, they learned had been treated not once but twice in the prior year with a very well-known fuel biocide, very commonly used. Yet that tank tested very high in total DNA. Well, that didn't surprise me. I've already told you. The biocide couldn't treat all the stuff that was growing in the slime and the sludge and the walls, etc. And this just backed that up. The most intriguing, of course, to us was that one tank down in North Carolina that had a history of severe problems, but when they tested this tank, they found very low levels of DNA, very little growing in this tank. So they asked about the history of this tank, and they were told by the owner that, about 6 months ago, he treated it one time with some biocide called Fuelrite. Fuelrite isn't a biocide. We know that. He should have known that, but he just assumed it was, since it was a treatment to fix stuff that was growing. But it just demonstrated to us what we always expected. The tank was relatively clean. So I'm gonna stop here and entertain questions, and but that doesn't mean we're done with you, because we're available. If you want to talk to me about anything technical or one of the others, I can pass questions to others, like Smitty, if we have questions in his domain. And my contact information is there. If you have questions of a sales nature and you want to talk to Dan Jenkins, who put this all together for us, his contact information is there. But I encourage you, if you're intrigued, if you're not convinced, for instance, and you want to see more, and you want to know more about how Fuelrite works or something, if you want to go to the website, fuelrite.com, and there's a little video, an animation there that shows how the Fuelrite works in the fuel system, and also a lot of test information and some technical notes and things of that sort. So, and also contact information if you didn't write it down here. So with that, I'm going to pass it on for questions. And here are some references where we found some of the nice materials that we used in this paper. Let's see what we have in the way of questions so far here.
Right here, Bob. Jim Kolkhorst has a question on busy truck stop. I assume, Jim, that gets loads every day. How long does it take for Fuelrite product to work? So, Bob, why don't you talk about these truck stops that get deliveries every day or every other day? Talk about the difference between shock and bulk, if you will.
That's sort of two different issues. But we have run into situations. You know, I tell people, look, 95 times out of 100, when you treat with this treatment, and keep in mind, we're not treating the fuel. We're using the fuel as a delivery system. We're treating the system. I think it's important to keep that in mind. We had situations where there was a lot of frequent or constant stirring of the tank. The first was a medium-sized tank that was at a fueling site for one of the big delivery companies, truck delivery. And these, the guy who filled the tank said he filled it almost daily. So you understand, there's a lot of turnover in this tank. And the truckers were complaining about a lot of filter problems, And so he was obliged to put a filter on the outlet to his tank, on the dispenser. And he said he had to go over there every day. He had to change the filter daily, or it would just plug up. This is out of his dispensing tank, so you know he was passing the problem on. And so we suggested he treat his tank. Well, he told us 2 weeks later, I'm still having to change the filter every day. The product hasn't helped a bit. And we realized what happened. He had a lot of sludge in his tank. And we don't make it go away overnight. It takes time to break it down and make it go away, but he was keeping it stirred up. So he was just carrying sludge over into the filter. If he'd stuck with it, eventually it would have stopped, but you know, he wasn't that patient. He just stopped using the product. And we started thinking about this. We call it highly agitated tanks. That was an unusual situation. Another case was a railroad. The short line railroad agreed to let us test one of their worst cases. They had a locomotive down in Alabama somewhere that was just pretty much dead in the water. He said it's so fouled, can't really operate it. So they agreed to treat that and try running it again. And they treated it and tried running it again and said, no, it's still kind of dead in the water. Problem didn't go away right away, and we realized, well, once again, you know, a locomotive is pretty much going to keep things stirred up. On the other hand, we've treated boats, many boats, tugboats, workboats, some of which had extremely bad problems. One of them was down to 8-hour filter life. I mean, it's hard to operate a tugboat that way. You'd think they would keep things stirred up, but we didn't have any of these problems. So it's hard to predict. Nonetheless, when we see what we consider to be a highly agitated system, instead of heavily treating to get rapid and instant results, we tend to take a more conservative role and use low-level treatment and tell people to lower your expectations a little bit. Don't expect instant things. We don't want anything bad, so we're going to lead you to a solution over a slightly longer period of time. Anyway, we're still fine-tuning that approach. But other than those sorts of situations, I struggle to think of any time we have seen a bad result of treatment. Now, how long does it take for it to work? It takes minutes or hours for it to start to work. Depending on how much accumulated sludge you have, it could take weeks or even months to really break it down. It might take several treatments over a year or two to really clean up a badly fouled tank. That's why I say if you want quick action, send somebody in to shovel and scrape. Don't mess with water blasting, sand blasting. Shovel and scrape. Get the bulk of the solids out of there, bring them out, close it up, treat it, refill it, put it in service. There will be no downside. There won't be a ripple with that kind of a situation. But you can save a lot of money by just treating, and just even if you have to change a couple filters before things settle down.
We have a question on biodiesel B5 and B20.
B5 and B20. Right now we're testing B2 and B20. Good point. Biodiesel is a coming thing, and a lot of you may or may not realize that in states that don't mandate it yet, and most don't, it is still legal. The ASTM specification for diesel fuel, number 2 diesel fuel, allows up to 5% biodiesel blended in without still being in spec, so they don't have to tell the customer this contains biodiesel. And in a practical way, people who know fuel systems have explained to me that, yeah, but, okay, the first guy that takes that fuel from the refinery says, good, I'm going to save some money and put 5% biodiesel in because I can. Because some types of biodiesel are cheaper than diesel fuel now, which is ironic. But palm oil, some of the types are cheaper than diesel fuel. So a fuel person can save some pennies by blending some in. So he puts 5% in. He passes it on to a terminal. A terminal says, oh, diesel fuel. Well, I'm allowed to put up to 5% bio in this without it telling anybody, not knowing there's already 5% in it, and now you got 10%. I mean, how long can this go on? I don't know. But the point is, don't assume that just because your state doesn't require biodiesel or your supplier doesn't tell you you're getting some, don't assume there is none in there. Now, there is a problem with biodiesel that I may go to my grave being the only person that admits this, because the people pushing biodiesel turn a deaf ear to this whole thing, and I don't blame them, because there's a lot of upside to biodiesel, and I love biodiesel for a lot of reasons, but if there's water and biological contamination in a number 2 fuel system with biodiesel, you get a black, sticky substance that forms in weeks, not years, starts to form, that is like, it's like soft tar, sticky, and it is so hard to clean off of things, and it can really mess up a system. It got a friend of ours to bail out of his heating oil business up in Massachusetts. He just couldn't handle it anymore. He tried to do everything right, said, every system has got this stuff in it. I'm not going to deal with this anymore. And I call it black honey. But when we analyze it, it analyzes as biodiesel. So that tells me that something about the bugs and the water and the biodiesel is causing the biodiesel to be polymerized to a semi-solid, sticky form that really messes up systems. So we're concerned about that as much as we are the other problems that happen in contaminated fuel systems. And I determined in my earlier testing that with 5 or 20% biodiesel blends, standard dose rates do not prevent black honey. They control corrosion. They control sludge as we know it, but they don't control the black honey problem. And it's appearing now in my current testing that maybe double dosing will. So I'm not proposing everybody rush out and start double dosing the world right now. But I'm just saying that it's a continuing study, and if you see anything that looks to you like black, sticky, lightweight tar, that is very, very hard to clean off of things and get off your fingers and get off of equipment. Think about it. Give me a call. We might be able to prevent that too, but it's going to take a higher dose. Okay.
One more question, Bob.
Yeah, Steve Gasell's question here. Are you saying that? I'm sorry. Are you saying that mechanical cleaning of tank bottoms is not necessary if your product is used, or are you saying your product and mechanical cleaning are the best method? I'm saying that mechanical cleaning is nice because we don't then have to worry about any repercussions, no matter how much you dose the tank. But it isn't really necessary that if you have a little patience and are willing to maybe replace a couple of filters, worst case scenario, or possibly not have to replace any filter, I would suggest you try treating instead of cleaning. So, which is better? Well, I can tell you which is a lot less expensive. And of course, with treating, you never have to take the tank out of service. Something else to think about. This looks like a long one here. Whoa, no, great. I'll look at why. Okay. Bob Glander, can you comment on the different filters that are being used? Different filters. Well, I think I know what you're getting at, Bob. In diesel systems, we find there are 2 kinds of filters that are very common: particulate filters and water-absorbing filters. We recommend, if you're going to treat with Fuelright, that you definitely use particulate filters. First of all, the water-absorbing filters are no longer necessary because the water is going to be handled. Any water that's picked up in the system is going to be handled with the fuel right treatment and passed through harmlessly in the first place. Secondly, because it's bringing extra water with the fuel, it will saturate and plug, therefore, a water-absorbing filter. So if you want good filter life, just switch to straight particulate filters. They're cheaper, and you'll be very happy. I think that's what you were talking about, Bob. Steve Cassell again. How long has Fuelrite been available to the public? We've been available since 1993. And if any of you heard about it before 2000, I'd be very surprised. I started small. We've never had a big advertising and marketing budget. And we are mostly getting around by word of mouth. I'll tell you one little story because it really irks me. I got a call one day from the Coast Guard. An officer at the Cape May, New Jersey Coast Guard station wanted to order some Fuelrite. Could they do that? I said, I think that can be arranged. So we sold them some Fuelrite. They loved it. They loved it. They never told us what they were using it for. We assume it's for heating the facilities or something, but for all I know, they may have been using the same fuel in their vessels. They didn't have a cutter, just had smaller Coast Guard vessels at that station. It was used at another Coast Guard station in North Carolina. They tested it. They liked it. We went to the Coast Guard. We said, look, your guys have tried it. Your guys love it. We'd like to sell more Fuelrite to the Coast Guard. The answer? I'm sorry. We've tested 2 additives for diesel fuel and determined that they are compatible with each other, and so therefore those are the only 2 additives that are going to be allowed to be used in Coast Guard vessels. So much for our career with the Coast Guard. It's been very frustrating. We talked to people from the Navy, and we told them that we can handle all your problems related from water getting in the fuel and contamination of the fuel, and they said, well, all of our ships of significance have water separators in the fuel system, so therefore we aren't going to have those kind of problems, so we don't need your product. We talked to an officer later who served on a naval vessel and worked directly with the engine problems, and he said, what was he smoking? We have awful problems with sludge in the Navy. But, you know, you do what you can, and we're a small company in a world of big companies, and but we think we have the technical background, we have the testing, we have the test results, and we have the very knowledgeable and trustworthy customers who will stand behind the product. And we can refer you to some of those people. Chris Hill, going back to the B5 issue with black honey, is it specific to the type of biodiesel or ingredients that go into the biofuel? Chris, I'm glad you brought that up, and I'm going to give you a real quick answer. I don't know, because the people who make biodiesel use whatever feedstock is readily available at the best price that week. And we tried to get biodiesel made from different feedstocks, and the people said, I'm sorry, it's all blended together in big tanks, and we can't tell you where that biodiesel is. So that frustrates me, because we know that the properties, cold flow properties and other things, very much depend on the feedstock. But there is no requirement that people who manufacture biodiesel stick with or report the feedstock used. So I struggle to answer that question. Most of my studies have been done with soy biodiesel, because I got that back before people started using all these other feedstocks in the mid-Atlantic states. But nowadays, what I have now in the way of biodiesel, I have no idea. Nobody can tell me what it's made from.
Okay. Well, Bob, thank you. Smitty, thank you. Panel, thank you. And all the audience, thank you. If you have any questions, just email me. I will have this recording available if you want it for future meetings or so forth. But this concludes our session. Again, I want to thank everybody, in particular associations and contractors that mailed in photographs. So with that, I'll say goodbye and thank you once again. I'm going to end the session. Thanks, Bob.